Okay, please inform everyone to join as soon as possible. Chalo, let's start. Okay, so till now we have discussed this about this thing, all right? Okay, phase diagram is done. Then we'll discuss about index property of soil. Okay, now basically whatever we have discussed, all are properties of soil, right? So in general, we can derive property and we can classify the property of soil in different categories. Okay, so mainly they are some geotech, you can say index property of soil, and other your engineering property of soil or geotechnical properties of soil, right? So basically, in soil mechanics, the properties of soils are broadly classified as index property and engineering property. Okay, here you can see the classification is given as, okay, index property and engineering property, and basic difference is what? From index property you can identify the soil behavior, and engineering property basically they are applied property. Okay, that means based on the index property you can identify the soil, and this engineering property are basically used in the design of the soil. Fine. So right now we are going to discuss about ये क्या आ गया? Wait. Okay, we are going to discuss about this. Fine. So basically, under index property, we have this total six. कितना आ गया? Six index property of soil, like specific gravity, moisture content, particle size distribution, in situ density, consistency limit, and relative density. Okay, and we can also determine these parameters even in the laboratory, in our soil mechanics laboratory. You have also done this laboratory. Moreover, I also share some link of lab demonstration in your WhatsApp group. Okay, for individual taste. Fine. Regarding specific gravity and moisture content, we have already discussed, right? What is moisture content? What is specific gravity? We have discussed, right? So by definition, we know these things, but how to determine moisture content or water content in laboratory? There are different tests that can be carried out in laboratory to determine water content or moisture content. But most accurate method to determine moisture content is your oven dry method. Okay, when you come to laboratory, I will show you. I think you have also seen in the when we were in the laboratory. So there are some thermostatically controlled oven. Using that oven and using oven dry method, we can determine moisture content or water content of a particular soil accurately. Okay, rather than oven dry method, there are different methods like sand bath method, calcium carbide method, okay, alcohol method, okay, radiation method. These are lots of methods are there, but among them, oven dry method is the most accurate, and calcium carbide method is the most weakest method. But it is not accurate. But if you want to know the water content or moisture content for a soil quickly, so you can go for calcium carbide method. Okay, but to go for accurately determination of moisture content, you have to go for oven dry method. But this particular sample, moist sample, you have to keep in oven for 24 hours. That means to get the result you have to wait one day, minimum one day. Okay, so regarding specific gravity, about definition we already discussed about specific gravity, right? So specific gravity of a particular soil solid is defined as a ratio of what? Unit weight of solid by unit weight of standard water or distilled water at standard temperature of 27 degrees Celsius. And specific gravity can be determined by two ways, using pyknometer apparatus or using density bottle. There are two approaches that can be followed in laboratory to determine specific gravity. Clear? I'll show you here. Here you can see specific gravity. It is one approach is your pyknometer. This is the pyknometer. Here you can see. Okay, this is a pyknometer. So this pyknometer can be used to determine the specific gravity. Other method is also there, density bottle. Okay, even in our department also, in our laboratory also, density bottle is also available. So you can also go by using density bottle. Okay, and I'll give you the demonstration for this, how to go for this test. I'll share some video for how to conduct the laboratory work for determination of specific gravity, moisture content, and others. Okay. So new things here: particle size distribution, in-situ density, consistency limit, relative density, right? So since you know the particles in nature, basically, the soil particles are not of similar sizes. If you draw this, okay, if I draw just a line so that I can represent, okay, so starting from very small size, different size of soil particle may present in nature like this. Okay, so that you can, so that to make you understand, I'm showing this. Okay, so that you can have some understanding. Okay, so I just want to tell you that soil particles are not of same size and not of same shape. The shape and size of the soil particles are different to each other. Okay, and based on sizes, the soil particles are classified under different head. These are soil classification based on sizes. Okay, so the lowest soil is known as clay, then silt. Okay, so I'll show you one soil classification. Wait. Hmm. Here in this diagram, can you see? These are represented in terms of sizes. Okay, these are represented in terms of sizes. So basically, in this table, the size of the soil particle is increasing in this direction. Increasing in this direction. Okay, 2 micron means what? It is a smaller of millimeter. 2 micron means your point 0.002 millimeter. 0.002 millimeter is your 2 micron. Okay, that is your 75 micron is what? 75 micron is your 0.075 millimeter. 0.075 millimeter. Okay, so here you can see from this side your size is increasing, 2 micron, then 75 micron, increasing. From here it is coming as 4.75. It is not micron, it should be millimeter. Okay, 4.75 millimeter. Okay, then 80 millimeter, then 300 millimeter. Okay, so it goes on increasing. So based on sizes, soils are classified under this. Okay, if the soil particles are having sizes more than 300 millimeter, these soil are known as basically boulder. Okay, and if the soil sizes are in between 80 millimeter to 300, they are known as cobble. And the soil having sizes between 4.75 millimeter to 80 millimeter, they are known as gravel. Okay, then from 75 micron to 4.75 millimeter, these are known as sand. Under sand also some classification are there: fine sand, medium sand, and coarse sand. Same way, if your soil is having sizes less than 71 micron but more than 2 micron, then soil is silt. Then if your soil sizes less than 2 micron, they are known as clay. Okay, so we can say clay is the smallest soil particle. Clay is your smallest soil particle. Okay, then silt is just larger than clay. Sand is larger than silt. Gravels are larger than sand. Cobble are larger than gravel. Boulders are larger than cobble. Okay, this chart you should remember. Even for gravel also some sub categories are there. It is not mentioned here. Anyway, it is up to 20, I guess. 4.75 up to 20, it is fine gravel. From 20 to 80, it is your coarse gravel, like this. Anyway, we don't need the gravel part. We need this part only. We need this part only for soil. Okay, so basically, if your soil, if more than 50% of your soil are less than 75 micron, then this particular soil is known as fine grained soil. And if more than 50% of the soil sizes in your sample is larger than or higher than 70 micron, then that type of soil is known as coarse grained soil. Okay, I'm repeating again. If in a particular soil sample, more than 50%, more than 50%, 50% of the soil, more than 50% of the soil having sizes smaller than 75 micron, then that type of soil is known as fine grained soil. Then the soil is known as fine grained soil, fine grained soil. Okay, and if more than 50% of soil, if more than 50% of soil is larger than 75 micron sizes, that soil is known as coarse grained soil, C-O-A-R-S-E, C-O-A-R-S-E, coarse grain soil. Okay, so this is a basic definition based on particle sizes, soil particle sizes. Okay, fine grained soil and coarse grained soil. Okay, under fine grained soil we have two type of soil, one is clay, one is silt. Under coarse grained soil we have two type of soil, sand and gravel, and these are basically are all are aggregate. Okay, so coarse grained soil means sand and gravel, fine grained soil clay and silt. Okay, and what is the smallest sizes of soil? It is your clay. Clay is the smallest size, having size less than 2 micron, that is your 0.002 millimeter. Okay, this thing you have to know this thing. Anyway, so here about particle size distribution. Particle size distribution is what? To know this parameter, this particle size distribution, it is done in laboratory, in soil mechanics laboratory, to understand the different grade of soil. That means the presence of different sizes of soil. That means constant sizes of soil are present in which percentage. That can be understood by this parameter. That is your particle size distribution. Okay. So particle size distribution is done. Particle size distribution is done uh, in laboratory to know the grade of soil. Okay, there are basically two grade of soil are present. Okay, that is your first is your well graded soil and poorly graded soil. Okay, I'll give you here. So if I tell you about grade of soil, grade of soil, there first one is your well graded soil. Okay, so what is well graded soil here? The well graded soil have a representation of all particle sizes. Suppose you have a soil sample, okay, and this if this particular soil sample that you have in the particular soil having it has all soil particle of different sizes in approximately equal percentage, that in that case that particular soil is known as well graded soil, and if it is not, then it is known as poorly graded soil. Okay, what is well graded soil? It has representation of all sizes of particle. That means it has all sizes of particle. Okay, but if it is not, then it is known as polygraded. It is the opposite of well graded. Okay, under polygraded soil we have another different heading. It may be uh, uniformly soil and gap graded soil. Okay, so it may be uniformly graded soil or graded soil. So uniformly graded soil means what? Suppose you have a soil sample, and in that particular soil sample all particles are of almost same size. Suppose all soil particles are of same size, says 2 millimeter. May I say example there now. Suppose all soil particles are of 2 millimeter size. That means you can say that particular soil is uniformly graded to the size of 2 millimeter. Uniformly graded means a particular soil having a majority of soil are having common sizes, equal sizes. Okay, then that type of soil is known as uniformly graded soil. But well graded soil is what? In case of well graded soil, it contains all sizes of particle. Okay, it's a good representation. It has a good representation of all size of particle. Then it's called well graded soil. Uniformly graded soil क्या होगा? It contain only one major sizes in a particular sample. Okay, now this is called uniformly graded soil. Now what is gap graded soil? Gap graded soil is just like well graded soil, but what is the basic difference is that in gap graded soil certain sizes are missing. That means suppose these are represents well graded soil, and if I just taking away these two sizes, मैं इस दो size को बाहर निकलाता हूँ, that means there is a gap between these two. So we can say this represents your gap graded soil. That means it almost well graded soil. Gap graded soil is almost well graded soil, but it is not well graded because certain sizes are missing. Okay, and if I put again here, it become well graded soil. And if I take any one from the sample, it will become gap graded soil. Okay, and if the soil having whole sizes are same, then it is known as uniformly graded soil. Okay, so to know the grade of soil, what is the grade of soil? What is the combination of the soil sizes? क्या क्या sizes का soil particle presence है in a particular soil? To know this, we can go for these sieve analysis. Okay, so they are the sieves apparatus. Okay, so how to go for this sieve analysis, we are also going to, I'm going to give some video link in the WhatsApp group. You will just go through the video, you will understand. Okay, the basic sieve analysis, how to go for doing that. Okay, this is for basically coarse grain soil. Okay, that is for sand, gravel, classification of sand and gravel, we can go for sieve analysis. For fine grain soil, that particular classification is done by hydrometer analysis or pipette analysis. Basically, it is known as sedimentation analysis. For theoretically, you have to know this thing. For coarse grain soil, we can go for dry sieve analysis or wet sieve analysis. For fine grain soil, we can go for sedimentation analysis. Under sedimentation analysis, we have hydrometer analysis and pipette analysis. Okay, so we're going to discuss. I'm going to give this how it is done in laboratory. I'm going to give all these details. Okay, about this. So this is done particle size distribution. Next, we can go for in situ density. So basically, you know what is density? It is mass per volume. And what is in situ means what? What is infill density? In situ means infill density. Okay. So to find out the in situ density, we can go for two tests: core cutter method or sand replacement method. Okay. Even in our laboratory, I think we have done this core cutter method. If not done, we are also going to demonstrate these things. Although I'll give you a nice video link for you so that you can have a good idea about how it's done. That means how a fill density can be determined in laboratory. Okay, fine. So this is about your index property of soil. Next, we have to discuss about consistency limit and relative density. Okay, so these things are discussed now. That is specific gravity, moisture content, particle size distribution, in situ density. These are discussed now. Next, discuss about consistency limit and relative density. Okay, wait. Yeah. So to understand consistency of soil, so basically the consistency means what? How can we deform a soil mass? Okay. How can a particular soil mass can changes its volume? How can a particular soil mass can changes its volume with the availability of water? That can be defined by consistency. Okay, and this consistency limit, it is basically represents for fine grained soil. Okay, it is basically applied for fine grained soil whose consistency depend on its water content. Okay, and consistency, it is the what? It is the relative ease with which soil can be deformed. And this consistency, about consistency, it is derived by A. Atterbuck. A. Atterbuck, it's a scientist, name of a scientist. He derived the concept of consistency in 1911. Okay, that means using this we can say whether the soil is stiff, medium stiff or highly stiff depending on water content. That means fine grained soil, I'm talking about fine grained soil, that is clay soil and silty soil. The fine grained soil are have a capability of changing its volume in presence of water. Fine, so this can be explained by this diagram. Okay, so this diagram, it is for consistency limit. If you can understand this diagram, you can understand the consistency limit of soil. Okay, wait a second. So here you can see in x direction your water content is increasing in x direction, and in y direction you can see it is represent volume of soil. Okay, now these are the variation of the, this is the variation curve of void versus moisture content, this one, the red color one. Okay, that means suppose if you consider a three-phase soil, let's draw a three-phase diagram. Let's consider a soil is there, a dry soil. Okay, a dry soil mass is there. So in that case, as dry soil mass having some क्या होगा, ड्राई सोil में क्या होता है, एयर होगा, voids में एयर होगा, isn't it? यहाँ पे solid होगा, इधर एयर होगा. Since it is dry soil, it water नहीं होगा, isn't it? So there will be air and soil solid. Okay, and it must contain some volume. Some must contain some volume. Suppose at moisture content at 0, ये point क्या represent करता है, 0 at 0. So at 0 moisture content, that means for dry soil, suppose the volume is capital V for this soil, any soil. Okay. Now if I slowly increasing or adding water in the soil, क्या होगा? That means if I go up to this point or up to this point or up to this point, anyway, suppose this much amount of water you have added in the soil, क्या होगा? Slowly, whatever voids may present in the soil mass, the voids are starting filling up with water. Okay? But volume of the soil mass remain same because water only replacing air right now. The water is replacing the air which was present before in dry soil. Okay, before enter of any water, that means at 0 point, that means when water content is 0, the soil is in dry state. In case of dry state, it contains only two components and it is in a two-phase system. It contains soil solid and air in, okay, air in voids. Now if we started adding water slowly, what will happen? The water start entering in the voids and replacing air. So till this point, if you start or increasing the water content, the water taking the place of air and it will replace the air and it will be there in the voids. Fine. Up to this point, only in up to this point. Okay. And if you increase more water beyond this line, what will happen? You can see if you increase more water, your void volume, total volume get increased now. That means what? Up to this point, the whole voids are get filled up with water. That means the soil is saturated. Whole voids are filled up with water. Okay, there is no space for water anymore. Again, if you again try to enter water, what will happen? There is no space for water. Then what will do? The soil mass increase its volume to get the new entry of water. It will increase its volume. ये वॉल्यूम ऐसे इंक्रीज कर देगा, अपने आप इंक्रीज कर देगा. एक सेकंड, होल्ड ऑन. ओके. Okay. So I'm talking about this. That is, if you increase water from here to here. Oh, wait a second. Yeah. Okay, am I audible?
Yes, sir, yes.
Okay, ठीक है. My network got stuck there. Okay. Okay, I'm talking about this. So if you up to this point, up to this point, you can see the volume of the total volume of the soil is not increasing. That means the water, whatever water we are adding in the soil, in the dry soil, it only filled up in the voids. Okay, but whenever we increase more than this point, then what will happen? The voids, the volume of the soil is get increased. Okay, again it goes on increasing now. That means the volume of total volume of the soil get increasing with increasing in the water content. Okay, so like this we have divided some zone in this graph. First graph part is your solid state, then semi-solid, then plastic, then liquid. Okay, and the moisture content or water content in between the liquid state and plastic state, it is known as liquid limit. The liquid limit between plastic and semi-solid state, it is known as plastic limit. And the liquid limit, sorry, and the moisture content, which is in between semi-solid and solid state, it is known as shrinkage limit. Okay, the shrinkage limit, plastic limit, and liquid limit, these three are basically known as consistency limit or Atterberg limit. Okay, these are basically known as shrinkage limit, plastic limit, and liquid limit. These are known as um, Atterberg limit or consistency limit. Okay.
Why, sir? Why it is,
हाँ
saying like
बोलो
plastic limit?
क्या
Is do they show the property of plastic or what
see why
in
you
the
are asking
plastic
so
limit?
much thing. Okay, I'm coming to this point. Okay, have some patience. Okay, have some patience. Don't ask anything stupid. I'm coming to this point. Okay, anyway, so now let's come to the first liquid limit. Okay, so what is basically the basic definition of liquid limit here? So basic definition is what your Atterberg, it is the Atterberg water content between plastic and liquid phase of soil. It is already known from the graph. Okay, so liquid limit, it is the moisture content between liquid and plastic state. Okay, liquid and plastic state. Okay, and another definition of liquid limit is what? It is the minimum water content in the soil where it behaves as a plastic material. Okay, that means we're talking about this, why it's called plastic and why it's called liquid. Okay, so it is a minimum water content. That means liquid limit represents a minimum water content at which the soil still in a plastic state, but if you increase more water content beyond this liquid limit, it become liquid. And what is the liquid, what is the physical situation of for this soil? The soil behave like a liquid, it will flow like liquid. If the soil moisture content crosses the liquid limit, the soil behaves like a liquid. Okay, now when it comes to plastic, yeah, now plastic limit. Now see, plastic limit is what? It is the minimum water content in the soil at which if you make a thread of diameter 3 millimeter and if you roll in your glass plate, it will crack. Okay, I'll explain these things anyway. In other words, it is arbitrary water content between plastic and semi-solid state. Okay. Now anyway, let's come to this point. So whenever a soil is in this region, that means it behaves like a plastic. Okay, so I think you have seen now Durga Puja is coming. More lots of the culture maker are making muti, right? Isn't it? Statue of Durga Ma is going on, construction of this going on. So if you ask them, if you go there, if you see, they are using plastic soil. Okay, so what is the basic idea about plastic soil? So plastic soil have a capacity or property of deforming without changing in volume. So you can give any shape to the particular soil. You can give any shape to the plastic soil without changing in volume or without failure. So this is a very significance of plastic soil. And whenever a soil having moisture content in between plastic limit and liquid limit, the soil is behave like a plastic. Okay. And this point, the plastic limit, it represents an arbitrary moisture content between plastic and semi-solid state. Fine. And this shrinkage limit, same way, shrinkage limit is the moisture content present in between semi-solid and solid state. Now, what is solid state? You know these things, right? What is the definition of shrinkage limit? If you reduce the moisture content beyond this shrinkage limit, then what will happen? There will be no change in volume. This is the main significance. If you reduce moisture content less than shrinkage limit, there will be no change in total volume. You can see the line is going horizontal. There is no change in volume. This is a significance of shrinkage limit. Okay, and also shrinkage limit is the boundary moisture content between semi-solid and solid state. Clear? Yeah. So shrinkage limit, it is all the definitions are given here. So it is the maximum water content at which soil behaves as a solid material. It is the maximum water content below which a decrease in moisture content result in no change in volume. And in other words, it is the arbitrary moisture content between solid in the and semi-solid phase of soil. Okay. So if you understand this diagram, liquid limit, plastic limit, and shrinkage limit can be understood easily. Okay. So in our laboratory, in your syllabus, there is a test called liquid limit test and plastic limit test. Okay. So basically, this statement is basically derive the procedure of determination of plastic limit in laboratory. Okay, so you will not understand this now. I will give the video link how to go for determination of plastic limit in laboratory. After that, you will understand this statement. That means you have to make a, you have to first you have to take some dry soil finer than 425 micron sieve. Then you have to add some water, then make a paste, then make a 10 grams. You can take some 10 gram of soil within your hand, then make a roll, then using a glass plate try to make a thread approximately up to this point. You have to make a thread that is 3 millimeter. Then you have to check that in the thread, suppose this is your thread, suppose you have made this kind of thread, okay, of the soil. Then you have to check, is there any surface crack or not. Okay, if there is no surface crack of break of the thread, you can say the soil is still in the plastic state. That means if the soil reflect any crack or failure pattern in the surface, you will understand it crosses the plastic limit. That means there is no plasticity anymore in the soil. From that point, you can identify the plastic limit of soil. Okay. Anyway, from the next classes also, we're going to start physical class. Then we can discuss more clearly about that. Fine. Anything else? Let's say. Wait, these things are already discussed here. Anything? Yeah. Last thing we have to discuss about relative density. Let's see कहाँ पे हो गया. Okay, in this classification of soil, these things are already discussed. I think this chart is already discussed with you about Indian standard soil classification system. The soil are classified under two head mainly: fine grained soil and coarse grained soil, right? So previously I've already discussed this table, right? So under fine grained soil we have silty and clay soil. Under coarse grained soil we have gravel and silt, and very coarse grained soil we have boulder and cobble. These things are discussed already, right? About what is coarse grained soil, what is fine grained soil, these things are already discussed with you. Okay. About well graded soil, what is poorly graded soil, these things also discussed with you. Clear? And this is the graph showing different particle size distribution. This is a particle size distribution graph. You can understand this graph only when you understand the lab practical or particle size distribution of sieve analysis. So I will give you the link. After going through this link, you will understand this graph also. Okay. Yeah, these things are already discussed. Procedure of sieve analysis, these things we will get to know from the video link. Okay. These things also you will understand from the video link. These things also. Okay. So yeah. So this is all about today class. Okay, roughly we have completed the whole your first chapter. Fine. That is your first module. Clear? Just go through the whole recording and go through the notes that already given in your student portal. I'll share the video link of the all the lab test in your WhatsApp group. Just go through the lab test. If you can't understand, just get back to me. Clear? Chalo. So with this, I just want to close my